Ladies and gentlemen, please welcome from Cisco's Data Center Group, Vice President of Technology and Product Marketing and Solutions Engineering, Ram Appalaraju.
Good morning. So with a name like mine, I may have to start with the right pronunciation of it, right? So it's Ram Appalaraju. I'm from Cisco, run the product management, product marketing, and the solutions engineering for a broad range of data center solutions. That includes UCS server platform, Nexus switching, virtual services, software-defined networking, and the development environments associated with that. I'm delighted to be here, right? I was listening to Paul's presentation, and I almost felt like there's a high degree of overlap in terms of key messages and the value of the open environment that collectively Cisco and Red Hat and the open community is working together. No question in that mind. And I also saw earlier on that the audience here is from different parts of the US, different parts of Europe, even here South Africa, different parts of the world. And no question in my mind, open is the new language of the globalization, right? This is the way we see this. But particularly, I want to spend a brief amount of time today on how is Cisco approaching the development environment around the open, and what's our fundamental bridge between the value proposition and the intellectual property you contribute, you create, and us working with Red Hat to how these things manifest as the right applications that are consumed by vast amount of mobile users on a global basis. That bridging is what I want to talk about. Cloud changes everything. I think Paul talked about IT transformation. There's not a single conversation I've had in the context of data center transformation or IT transformation that did not bring in the notion of cloud at the architecture level, at the development level, and provisioning and deploying consistently a large number of applications. I say this for the following reason. I've been in the business for quite some time. In the mid-90s, when I was working with the mid and the large enterprises, I asked general question, how many applications do you deem as a mission-critical applications? The answer is usually a handful. There's an ERP, there's a supply chain, there's a database, there is a CRM, usually it's a spreadsheet, right? That's what it was. About 10 years ago, the number mushroomed from handful to tens to maybe touching in the 40s and 50s. Today, when I ask a CIO or IT architects, every one of my application is mission critical, including a Wi-Fi authentication application as people walk into their offices. Right? So the notion of any applications that you're getting in the developer side need to really deploy in a most consistent, predictable, scalable, unpredictable environment is how Cisco holistically looking at this opportunity. Right? That's where we're going to talk a little bit more about that. And this is the tipping point. I think virtualization has been around for a while. Now it manifests as the single largest initiative across all enterprises. But we also know at the same time, as market data indicates, over 75% of the enterprise workloads are virtualized, and these customers have benefited from significant CapEx reduction because they're using fewer servers more efficiently thanks to virtualization, but the data doesn't include the significant increase in the OpEx, the complexity associated with managing virtual environment, provisioning the network, the data, particularly in the environment around the big data, mobile applications, and so on and so forth, and that cost is not trivial. Our study shows more often than not the pure CapEx savings you get result of virtualization as you scale to larger environments for more application, the savings easily get eroded, and then you end up spending more, particularly if OpEx isn't considered as a part of architectural design, right? So given that, we see what we've been calling as Internet of Things, which means every living thing is a data source that contributes to some process, picks up the data, builds it into a workflow, and essentially builds the analysis capability and produces a result. The big data is an element of how this Internet of Things feeds into a larger environment. And of course, this data resides in the cloud, and the application that compute on this reside in the cloud. And therefore, there is a high degree of interest in the market to be able to abstract the layer of complexity and be able to program this environment by software-defined infrastructure. It's not just networking, right? So we'll talk a little bit about that as well, how Cisco is approaching this. The way we started the problem is the developers are passionately developing the applications on the open environment, and they see the value in how the application behaves and performs. So when you start to bridge it to the deployment scenario, going back about maybe half a dozen years ago, the network or how the data center was essentially assembled, a set of servers in the network, wasn't always optimal, right? It required a manual programming of these infrastructure resources, the servers, the networking, the storage, so on and so forth. Very limited scaling of the applications within the confines of a rack, right? And that was only acceptable in a marginal cases. And then about 3-4 years ago, Cisco introduced the notion of extensibility through through a fabric-based computing, what we call the fabric path, right? And this provided ability to bring large-scale mobility for applications and essentially bridge between a physical data center and cloud-based resources. It still required a fair amount of part on IT to understand what the developers and application owners' intent is to be able to provision and optimize the infrastructure for deployment. Now, where we are is what we call the application-driven infrastructure, bring the higher degree of automation and orchestration to really exploit the entire resources with minimal or no human intervention. That's the architecture we are bringing to the table today, which means you have a collective set of compute resources and the network resources that are truly programmable from the application's perspective. What is implicit and transparent in this environment is the degree of capacity, scalability, response time, SLA management. All of them are paramount important to the business, or implicitly carried through the architecture level. So the net of this vision and the implementation path we are on is you can develop an application without constraints of deployment environment at scale, capacity, security, availability, reliability, so on and so forth. So we'll talk a little bit more about the bridge. So if I digress a bit, the notion of DevOps as a community wasn't even defined 5 years ago. Even Gartner picked that up, and they were literally contributing more in their own research. The changing role of DevOps, developers and operations type come together. They call the organization as DevOps. And what keeps them awake at night, or what are the driving factors of DevOps from the business application perspective on the one side, IT and the operations on the other side. So part of our vision here, how do you singularly balance that? Make DevOps very successful and literally take away the complexity of the architecture, complexity of operations, complexity of management, and yet give simple, easy, programmable interfaces so that the entire architecture can be customized for a given application workflows. Okay? So our vision fundamentally comes down to these 4 or 5 elements here, right? It really comes down to time to deploy and deliver an application. That's a fundamental tenet of business. I'm not kidding when I say this. One of the CIOs of a service provider shared with me his goal sheet. He's obligated to match or beat, or at least match, any competitive service offering within 30 days. It doesn't matter how long the competitor took to develop the application, but this CIO is obligated to match it because 30 days is about the maximum they can deal with having a competitive disadvantage. Right? So time to business deployment of applications and maximizing business value is of key imperative, and that comes from a variety of things, including the infrastructure attributes. Right? The second part of a vision is make our infrastructure holistic, programmable, and provide the infrastructure that truly brings the all elements, compute, storage, networking together. Okay? And this is, in a way, application agnostic, written in whichever language, whichever programming paradigm it is in. And this should be accessed at any location, really integrate into mobile application architectures. And this should be at any scale in an instant of time. That's a vision. That's the architecture I laid out before. And that's how we are trying to bring this together. So I won't go too much into the slide, but fundamentally, the open cloud environment, as we call it, is implicitly built around the open movement, and our partnership with Red Hat is testament to that. A vast majority of the components that contribute to our developer architecture is leveraging the best of the breed that exists, and this is also largely driven by the direction we get from enterprises and service providers. Right? And that, to me, is paramount importance to align with market forces, align with the language of the developer community, and give the assurances on how the development or deployment comes in. Now, I talk a little bit about making the programmability of infrastructure simple and easy. Right? About a year ago, we launched this, our strategy and the vision and the set of offerings in what is called Cisco One. Okay. There was too much buzz in the marketplace around two things. One, hardware is getting commoditized. There's some truth to that, and some areas I don't agree with that. I'll share with you why. And everything needs to be programmable, which is true. But there's no such thing as one size fits all. So we put in under Cisco One three fundamental elements that truly makes infrastructure more efficient to the applications. Right? One on the left, what we call one platform kit, or 1PK. We couldn't get more creative with the names, so 1PK should work. So the nature of 1PK, quite simply, is our intellectual property that we've been proud of for years is understanding the network details to the nth degree. We know which packet is going where, which packet has a mission-critical attributes, which packet has an SLA attributes, which packet gets dropped and we need to reroute it. And that's not something, I call it cool from a developer perspective to care about that. So what we have taken is the specifics of the data we collect as a part of the network and distilled it up with a layer of abstraction, made them into essentially APIs at the highest level and make them truly programmable with any formal high-level language. That's the path we are on. So which means the attributes that you can use to manage, automate, and really allocate the right amount of resources can be programmed right into the application workflows. Before that, that degree of programming was not under the control or ability of the programmers. It was something advanced IT staff with exceptional amount of certification, training, and skills could only perform. So how do you bring that disruption and make sure as you're developing the application, how you bridge it from a deployment perspective and connect the dots is critical element to 1PK. Since we announced 1PK sometime last May or June, we have close to now over 800 plus APIs that cuts across everything we do, every switch, every router, every virtual services stack. We have essentially driven that. The second aspect is what we call the software controller, one controller with appropriate application agents. And this is where we see the need to align with the industry forces around open flow and the open network foundation. So we are completely, not just the founding member, but we are contributing, in addition to 1PK, everything that is truly standards-based. Again, as I mentioned, OpenFlow is a great idea, addresses a lot of requirements that the market needs, but at the same time, the level of detail and the granularity, sometimes you get it better with 1PK, but the choice is imperative as we listen to the marketplace. The third one is the bridging the physical and virtual, and that's where the virtual overlay comes in. So we basically built a consistent virtualization platform under our Nexus 1000V, sometimes you call it 1K, Nexus 1K, and this gives kind of a hypervisor agnostic, but a large extent, the drive in the service providers and the enterprises has been around KVM, gives you a platform to really lay a platform on the broad range of level 4 through 7 services across physical and virtual that gives consistency and scalability. That architecturally, what we are calling it Cisco One. We are delivering the products today, we are shipping the products today, and there are more than the early tests, some deployment scenarios are in works with this architecture. Okay. So very quickly, the advantage of having this network virtualization for OpenStack, for example, is how do you manage the entire resources from different tenants and different virtual applications? Either it is providing the VWAS services or ASA firewall services all on a virtual platform, and be able to even address the needs of physical and virtual on a consistent basis. So from a programmer perspective, or application optimizer perspective, or application architect perspective, you never have to think of a divergence of physical architecture and a virtual architecture, but having a bridge between them is critical to essentially guiding the simplification for the data centers particularly, and that's where this contribution comes in. Okay? So that's in my 25-minute slide deck. I wanted to start with our vision and our programming direction, but I want to spend a few minutes on the deployment scenarios of why Cisco has got a different vision and strategy than a few of them believe that everything is getting commoditized, right? The infrastructure requirements haven't stayed the same. They have evolved significantly over time. Customers are not interested in purchasing compute, servers, networking, and storage. They're looking for a way to get a unified architecture with least amount of operational headaches, more importantly, highest value for an integrated converged architecture, right? And to address that, we focus not just on the cost point, but the value that the infrastructure needs to deliver. Areas of rapid provisioning, areas of simplification from holistically. I got some more information on this topic, right? Ability to align applications directly with the infrastructure and really enable the self-service concept so that you know the infrastructure is available when you're ready to deploy and optimize your application. And last but not the least, really ability to scale the application environment or capacity as needed, transparent to any intervention both on the application side and the IT side, right? And to do that, we started with an architecture called UCS, Unified Compute System. And the fundamental tenet to this is, why did we get into server business? In 2009, we had a grand total of 0% market share in the server business, and pretty well-established companies were deeply entrenched in blades and the rack-based architecture, and that's where the trend in the industry was. IBM's, HP's, Dell's, Fujitsu's, you name it, they were all there. But we wanted to not make another server, but really look at these applications differently. We walked into an environment where IT had a different subject matter experts. That's what SME stand for, a server experts, a storage expert, and a network expert. And they were tasked to really optimize this infrastructure depending on the application need. Some of you may know this term. If you go to a kid's birthday party, you see a game called Whack-A-Mole. And this is really what this has come to. And I have seen time and time again in my customer advisory boards and the feature requests that come our way is the finger pointing and how can we avoid that as one of the major requirements. And we started with that in 2009. So we built an architecture quite simply, taking in not just the blades, but drove into the heart of the blade our networking architecture, which means we wanted to really capitalize on ability of transforming the server architecture itself from purely an interconnect instead of CPUs and memory and disk hanging, and then there is a PCI and there is I/O, to really build a converged architecture with networking driven in. Our objectives were multiple. One of them is programmability of server and networking in unified environment. And more significantly, while we are using the same commodity components as everyone else, or more industry standard components like anyone else, like Intel x86 or the memory components or the disk components, we want to differentiate on efficiency and performance. Okay? Lo and behold, basically when we build the architecture, we also want to make it usable and accessible at the application level. Therefore, we created a notion of templates. And this template has what is called the framework for an application's DNA. And in the template, you populate with the application-specific attributes, what we call profiles. So once you do that, those profiles are essentially the specific attributes of all aspects of the system, compute, memory, networking, and I/O, and storage. That becomes essentially DNA of the application. Once you set that up, our architecture found the right area within the, that's by pretty fast, into UCS, finding the right VMs on the right CPUs at the right location on the right blades, transparent to the needs of application. And this could have happened across the cloud, across the data centers, across multiple data centers, because the methodology is consistent and it is orthogonal to deployment architectures. The simple answer, basically what came out of this, is really you can change the paradigm of server computing by literally bringing into a physical virtual cloud integrated into common architecture and really make that simple to deploy, simple to program from end to end. And if you net it out on that, from 0% market share in blades in 2009, a couple of weeks ago, IDC reported in the most recent quarter that ended on March 31st, we are number 2 in the market share in the blades. Okay, that didn't happen overnight, but it is a resounding success being in the business as the last server entrant and really get to number 2 spot in 4 years. And the business is growing at 77% per year, and we have customer adoption and acceleration simply on the rise, and backed by the large volume of channel partners and community as well. So the net of the message is the following. The developers need a better way to get the visibility into deployment scenario and ability to automate the optimization of the deployment scenario directly from the application standpoint. And our focus is on delivering the tools, and that tools developed or generated these results. Okay. So if I look at holistically, Cisco has been an infrastructure networking player for over 24 years or 25 years since being around. But over the last few years, we transformed ourselves from a pure networking company to data center company, from data center company to IT architecture company, from IT architecture company to essentially facilitating the developer community contributing to the open source and OpenStack and open tools. In fact, my colleague, Luke Tucker, is the vice chair of the OpenStack. So we have a lot vested in understanding what's going on in the developers' world and to really tailor our architecture, tailor our scenarios so that the bridge from development to deployment happens consistently. I made also a comment around the commoditization play. I missed that in the previous slide, but I don't need to go back. If you go to Cisco's website or any spec benchmark website or SAP benchmark website or you name it, right? UCS is up there at the top, right? We have nearly 77 world record benchmarks at the CPU level, at the virtualization level, at I/O level, at application level, you name it. The first question I ask is, about 10, 12 years ago when we bragged about the benchmark, people were asking, is a Spark better than PowerPC, Itanium better than this, PA Risk better than this, and the x86 comparison? They were really contributing to the significant difference in performance one over the other. Of course, there are some compiler attributes and other factors. Today, when people tell me, Ram, everything is getting commoditized, everybody is using essentially same components, x86 chipsets, and so on and so forth, what's the differentiation? My answer is exactly using the same components, system level is a differentiation that manifests truly as a difference in the application performance, and that's what we proved, right? So again, that is something I will always point to the developer community to pay close attention to. Fundamentally, when you're looking at the development stack, when you're looking at deployment environment, fundamentally understand the scenarios under which this is going to be deployed. Physical data center, virtual data center, on a cloud environment, but look at the environment that provides the smoothest and the simplest transition between the two. Okay? Although it is based on the commodity economics, I call it, the value differentiation is significant at the system level. Okay. So our relationship with Red Hat is very strategic. We've been closely working on a variety of projects related to OpenStack, to open environment. Cisco IT internally uses over 10,000 instances of RHEL. So we are a large consumer of this open environment, right? We have a deep interest in learning, working jointly with the Red Hat community and you all fundamentally to see where we can really take this environment next. And our job is quite simple. We want to essentially focus on deployment environment that simply makes developer friendliness into it, right? So I think that's fundamentally the message I want to leave behind this morning. I got a couple of more minutes, but I want to change the topic completely and look for, I mean, I mentioned briefly that the crowd here comes from different parts of the world, different parts of the area, and open it's a new language of the globalization. I'm from Boston. Although I work for Cisco, I'm from Boston, and this is a great city, and we all know what happened here a couple of months ago. And I wanted to really look for ways to cheer our Bruins in Boston here. Tonight is a big night. Of course, we are from Boston. And I'm saying go Boston and go Bruins. And let's go from there. Thank you.